In Module 1, we're going to introduce whole numbers. There are 3 sets of numbers we're going to talk about. The first set is natural numbers. We can think of them as counting numbers. The numbers 1, 2, 3, and then the numbers continue on. Add 0 to the set of natural numbers. Now you have a set called whole numbers. Add negative numbers to the set of whole numbers, and now you have a new set called integers. They include negative numbers, the number 0, and our positive or natural numbers or counting numbers. Long ago and far away, sometime during 200 to 300 BCE, the Babylonians developed a symbol that became the 0 that we use. It really started out as a placeholder to show the difference between numbers like 2 and 20. India was using it much earlier for pretty much the same reason. It's interesting to see that minds thought so much alike. Math really is a universal language. We're going to take a look at place values. Each of these words indicate a period. So in other words, trillions, billions, millions, thousands, and ones are periods. In the ones period, we have hundreds, tens, and ones. This pattern follows through in all of the rest of the periods. Look at thousands. You have 100,000s, 10,000s, and thousands. And in millions, you have again 100 millions, 10 millions, and millions. And so on, including billions, where you have 100 billions, 10 billions, and billions, and trillions, where you have 100 trillions, 10 trillions, and trillions. It continues on, but for the most part, we're just going to use these periods to help us get acquainted with place values and how the periods work. The Babylonians were the first to think about place value. Sometime between 2000 BCE and 1000 BCE, they were thinking about it. About 500 BC, India came up with a base of 10, and that is what shaped the place values we use today. It took a long time to come up with this system. Let's try naming the numbers that we see. We want to find out what digit is in the thousands place. And in this number, it's the number 2. So what digit is in the tens place in this number? It's the number 5. And what digit is in the 10,000s place? It's the number 1. We want to take a look next at what an expanded form is. Let's use the number that we used before. We have 312,658. We'll write each number multiplied by its place value. Here's what that's going to look like. Here's our number, 312,658. 3 is in the 100,000s place. 1 is in the 10,000s place. 2 is in the thousands place. 6 is in the hundreds place, 5 is in the tens place, and 8 is in the ones place. So let's write it now in expanded form. That means we're going to take the number 3 and multiply it by 100,000. That's the period and place that it's in. We're going to take a look at multiplying 1 times 10,000. We'll multiply 2 times 1,000 because it's in the thousands place. We'll multiply 6 times 100. We'll multiply 5 times 10. And last, we'll multiply 8 times 1. So now let's see what we have for a value. 3 times 100,000 is 300,000. 1 times 10,000 is going to give us 10,000. 2 times 1,000 will give us 2,000. 6 times 100 will give us 600. 5 times 10 will give us 50. And 8 times 1 is going to give us 8. So now we've multiplied each of the numbers. Each of these digits were multiplied by their respective place value and expressed as a number. And now we're going to go ahead and add them. Let me show you a quick way to add these numbers. We're going to stack them, and now we're going to start on the left-hand side. There's nothing for us to add in this column except the 3, and we bring it down. Same thing in this column. We bring the 1 down, and now we bring the 2 down, and there's our comma to separate our periods. We have 6 in this column, we have 5 in this column, and 8 in this column. It was a pretty simple addition to do, but lining it up like this makes it easier for us to see what our final value is. We'll revisit this whole process later on when we get numbers that have something other than just a lot of zeros in them.